right, guys, so we're going to do a quick little recap on systems. So taking a look here, we talked about inequalities when you go to graph the line. So I just wanted to recap with you really quick. These ones are pretty straightforward, guys. You can type these equations or inequalities into Desmos, and it'll graph this for you. So use that tool wisely. But I do want to give you a quick little, reminder that you see on the blue line here that it's solid because this is less than or equal to. It has that little equal line underneath. Why the red graph is dotted is because it has strictly greater than. There is no underline underneath it. But remember, just graph those in Desmos. Type in those equations and you should be good to go. All right. Now, the systems of equations are two equations that you graph at the same time. So you guys love this because Desmos will graph those for you and you can tell what type of solutions it will have. So the key word here is solutions. It means where do I cross or intersect? So we had three possibilities that ended up happening here. Either we cross one time, which was a point. In particular, this guy would have been 1, 2 as the solution. Or you could possibly have a setup where your two lines never cross, which is also a potential thing that happens there. So if they never cross or touch, you have no solution whatsoever since they never cross. If you have two lines that end up just making one, it means that they're overlapping, which means that these two lines will touch literally for the entire length of the line, which we call infinite solutions, which means that they will touch infinitely, which makes sense. If they're overlapping, they will continue to touch or cross each other at infinitely many places. All right, guys. So taking a quick peek here as well. Another thing that we talked about is elimination, and this is something that you will see with systems as well, that in order to eliminate in your system of equations, you have to have a positive and negative pair, and you have to have the same number in front of the variable that you want to get rid of. May it be x or may it be y. So for an example here, it says, what number would you multiply the second equation by to eliminate x? So we're going to focus our attention here on x. And right now I see that I have a 2x and a positive 1x. Remember, in order to eliminate, I have to have the same number in front of the variable of x. So I need to force this second equation to have a 2. But don't forget, we also have to have a positive negative. So we also need to have a positive 2x and a negative 2x. So since the top piece already has a positive 2x, we're going to force the second guy to take the negative. So then we can actually eliminate the x's. So 2x minus 2x would end up giving us no x's whatsoever, which means that our answer choice that makes sense is making sure that I multiply that second equation by negative 2 in front of everything. All right, so taking a look, guys, another possible question is dealing with y's. So it says, what numbers would you multiply by to set up elimination for the y variable? So you'll see that I kind of took it out here and set it out to the side. So notice we already have a positive negative pair. That's good. So we already have that positive negative pair. And now we have to figure out how are we going to make a 2 and a 7 the same number in front. Now, there's always a quick way to do that, guys. So to get the same number in front, I'll just put same number in front. Since these two numbers are completely different, the 2 and the 7, we're just going to multiply them together. So that gives you 14, which means to fix this issue, we could, in fact, multiply the top equation by 7, and we'll multiply the bottom equation by 2. That way we'd get a negative 14y on the top and a positive 14y on the bottom. That would help us eliminate. Those y's would literally undo each other. They're gone. All right, so hopefully that helps you recap on eliminating. And now let's get into our favorite, the word problems. So please, please, please pay mind and pay attention to what the question is asking. So again, remember, you're going to set up an equation. So you may want to pull some information out of here. Like for instance, it says a jar contains only nickels and dimes, and you have a total of 60 coins. So if I take my nickels plus my dimes, I will have 60 coins going on in here. So already I can X out letter A because that equation is not in the setup whatsoever. Now, if I do the rest of the question here, it says that the value of all my coins is $4.45. So don't forget, guys, if they give you money, you need to use your nickels and your dimes, and you're going to give me the value, the money value of each of those coins. So dimes are worth 10 cents a dime, and nickels are worth 0.05 or 5 cents per nickel. So as you look at that setup, please note that B is very close, except it has 0.50. That means that's 50 cents per nickel, and that is not truthful. So B is out. And as you look forwards there, C is also out, which means it is probably going to have to be D is our answer choice. All right, last one. So a couple different ways you can handle this guy. It says 2 customers went to the post office. They bought postcards in large envelopes. They talked to you about different customers. So I'm going to set up my equations from each customer on the side. So the first customer is represented by 14p plus 5e, and that all totals to $12 or equals 12. And then the second customer has 10p for postcards and 15e for envelopes. And when I add those together, I spend, or the second customer spends $24.80. So now if we were to type these equations into Desmos, so we're going to put that into Desmos, guys. Please remember that Desmos will only take X's and Y's as your variables. So I would use X as P for postcard and Y would be E for envelopes. So what we're looking for is where do these two lines cross? So we're going to identify that point here, and that's what we're going to use as our solution. So 0.35, comma 1.42. So here at the end it says, what was the cost in dollars of each large envelope? So I'm going to remind you guys that you and I wrote our equation with large envelopes represented by the Y value, or that's the letter we typed into Desmos. So right now, according to your solution, our solution has the postcards as the X and our large envelopes as the Y. So if they're asking you how much did it cost per large envelope, you will use only the Y coordinate. Oops. Get out of there, Miss Weldy. Hang on, guys. All right. So we are only using not the X value, but the Y value, which ends up being $1.42 for each large envelope. All right, I hope that helped you out to recap on your systems, guys. Please go into Edulastic and complete your systems review.